All right. Today we want to look at mole concept. That is, what's the concept of a mole? A mole is a unit of the measurement for amount of substance or particles. Just like any other quantity, a mole is a quantity. Probably if you talk about a dozen, which is 12, you talk about a pair, which is 2. So that is what a mole is. It's a measurement, unit of measurement for a substance. And if you look at this, we have 1 mole equals to what? 1 Avogadro's number, which is 6.022 times 10 to the power 22 particles. So it means that in 1 mole we have 6.022 times 10 to the power 22 particles in 1 mole of a substance. That's just the concept of a mole. So with this, you'll be able to calculate how many particles are there in a substance, or how many mole are there in particles. So it shows that the Avogadro's is telling us 1 mole equals to what? 6.02 of times the power of Avogadro's number. Then what? But if you are talking about mole, there are some key terms we need to know, like the molar mass, that's mass of 1 mole of the substance in gram per mole. That mole itself is N, which is amount of substance or amount of particles in a substance, or just the amount of substance. Then we look at, as we have mentioned, molar mass, mole. Then we took up mass of that substance. Then we also molar concentration. Molar concentration equals to mole per liter, and so that is some of the things we need to know about the mole. Then what about calculations involving a mole? If you are looking at mole concept, the basic formula there which you need to know is the fact that 1 mole, or just like a mole of substance, equals to what? Mass over molar mass. That's N over mass over big M, that is molar mass. So the mass in grams, then the molar mass in grams per mole. Then another formula is what? Molar concentration equals to what? Mole over volume. So that's C equals to NV. And we still have one other formula talking about if you are talking about in an ideal gas situation, or probably you are putting an STP, that's EV equals to nRT, which I'm still going to tell you about that. So that is that. And also let's look at, and I've told you that the mole is calculated by what? Mass over molar mass. So now it means that we are going to calculate the molar mass of a substance. Then you know the mass of the substance in question. Then you start solving. Now let's look at this example. How many moles in 20 grams of sodium hydroxide? How many moles are there in 20 grams of sodium hydroxide? Then we have, in the question, we are given the mass, which is 20 grams. And we are going to calculate the molar mass of sodium hydroxide ourselves. So now let us see. You see, mole equals to what? Mass over molar mass. That's 20 over 40. Then how do we get the 40 grams? The 40 grams is just calculating the molar mass. And how do you calculate the molar mass of sodium hydroxide? That's Na plus O plus H. The atomic mass of Na is 23. Then the atomic mass of oxygen is 16, while the atomic mass of hydrogen is 1. So 23 plus 16 plus 1 give us 40 grams. So if I'm to do that, so we have what? 23 plus, so we have 23 plus 16, then plus 1. So that will give us 40. So that's how we are able to get the 40. So if you divide 20 over 40, that is 0.5 mole. So the answer to that question is just 0.5 moles. So how many moles are there in 20 grams of sodium hydroxide? Then how many moles do we see? We see 0.5 mole. Then look at another question here. Let's look at, they say, how many moles in 50 grams of calcium carbonate? Calcium carbonate was CaCO3. Now the basic formula is what? N mole equals what? Mass over molar mass. The mass has been given to us as 50 grams. Then we are going to calculate the molar mass, which I did in this place. You can see Ca plus C plus O3, not CO3. Have you seen it? Ca plus C equals to, now what's the atomic mass of Ca? 40. And what's the atomic mass of C? 12. Then 3 times 16, that's 48 plus 12, and so we have 100 grams. So that's, we have the molar mass is 100, and what the mass? So 50 over 100 equals to what? 0.5 mole. I think that is that. I think that's a very simple calculation. So mole concept is not that hard. Just moles equals what? Mass over molar mass. Then the other formula which involves concentration, like concentration of 0.02 sodium chloride in 500 ml, you can see that's equal to what? N over V. Mole in that thing is what? Concentration is 0.2 over 0.5 liter. Then you have your answer 0.4 mole per liter. So that is that. And now you can see, let me give you another question. This one is just straightforward. If 2 mole, we are not talking about other subject, probably you see simple example, and when you get to classwork, it seems harder. But this one is just a concept. So mole equals what? Mass over molar mass. But sometimes the mass might not be given, then the mole might be given. Then you can actually say that mole equals what? Mass over molar mass. Then if you are looking at make mass a subset of formula, then it was what? Molar mass times mole. For example, look at this question. If 2 mole of HNO3 was produced during a reaction, what is the mass of the acid? Now look at the atomic masses. That's HNO3, that's the nitric acid. Then the formula is what? Mole equals to what? Mass over molar mass. You can see. So if you have mole equals what? Mass over molar mass. Then the molar mass, let's calculate the molar mass. That's H plus N plus O3. That's 1 plus 14 plus, that's 63 grams. So in fact, if I have 63 grams here, I already have my molar mass. And in the question, I was not giving mass, I was giving the mole. So it just what? What is the mole in the question? The mole in the question is 2. You can see. So 2 times 63 is 126 grams. So now I'm able to have my gram back. So this is just a simple way of, you can see it's very simple, that we have a mole and we calculate the molar mass ourselves. Then you can see that's 2 times 63, which was 126. So that's the third example, that's the third question we're looking at. And I said lastly that we can have mole in an ideal gas situation, or what? At STP, not at top, at STP. And the formula there is what? PV equals to nRT, where N there is the mole, like you can see, where N there is the mole, and V equals the volume in dm cube, T either degrees Celsius or Kelvin, P in atmosphere, then R, that's the gas constant. So if you use this formula, make N separate of formula, and which is what was PV equals to nRT, then we have N equals what? PV over RT. Then you calculate your mole in an ideal gas situation. So that is the concept of mole. So in the comment section, I'm going to put some questions there, probably OG question or theoretical questions there. Solve one of them. The answers, I'll put the answer there. So this is just a short one. The next one, I want to look at, I don't want to assume that probably, I want to see, my next video will be on molar mass, then with some questions. So I think that is that. So I think we've been able to look at everything about the concepts of mole. Now we talk about mole concept, medium measurement, and how to calculate it. So that is it. Thank you. See you in our next video.